Squeeze all this stuff in here. All right, so we left off here, and we're trying to do both of these transformations. So the first one, we're taking this terminal alkyne, and then we want to add 2 carbons to it. And normally we would just hit that with sodium amide to do the deprotonation, and then we'd use ethyl iodide and then call it a day kind of thing. The problem is if you have the amide ion here, that's going to be a good nucleophile. And so that is going to do a nucleophilic attack in our carbonyl. So that's not good. We don't want to do that. And thus, we need to protect that carbonyl group first. So what I'm going to do is I'm going to switch over to a blank document here, down here. And I'm going to draw this out so I have a little more space to work with. So this is 19.10A. And so while I'm writing this down, could anybody recommend a way to protect that carbonyl group? And it's not a trick question. What I use, I'd use an acetal, right, Juan? And I'd make it from the diol, right? So the first thing I'm going to do is I'm going to treat it with ethylene glycol, okay, a catalytic amount of acid. And I always write minus H2O because you need to remove water from the reaction mixture when you make an acetal. And that would make the cyclic hemiacetal. So I have the 2 carbons in there. Then I have my triple bond like this. And now I can add my ethyl group. So the first step is going to be sodium amide. And this is just chapter 9 chemistry, followed by ethyl iodide. And that's going to install my ethyl group. There's my ethyl group. And then the last step, all I have to do is treat that with aqueous acid. And so I'll just put here H3O plus, excuse me, or you can put H2O and H plus, that will work. Either way, just dilute acid is going to remove the acetal. There we go, there's that one. And then in the next one, I'll see if I can squeeze it on here, B, we have a carbonyl from a ketone, and then we have a carbonyl from an ester. And what we want to do is we want to make a tertiary alcohol. Okay, so we want to make a tertiary alcohol here where we have 2 aromatic rings. And of course, you would have to use Grignard chemistry to do this, right? We can think of this in terms of taking this compound, right, the starting material, and then treating it with phenyl magnesium bromide, right? Excess phenyl magnesium bromide. The only problem with that is that the phenyl anion would do a nucleophilic attack on our carbonyl. And so we want to avoid that. And so we're going to have to do the same thing that we did before, and that is to protect the carbonyl as a cyclic ether, or sorry, cyclic acetal. So we're going to treat it with ethylene glycol, a catalytic amount of acid. We're going to lose water, and we make our acetal. Still have our ester intact. And now we can treat this with 1 excess phenyl magnesium bromide. Maybe I'll just draw the intermediate that's formed here, right? Because after you treat that with excess Grignard, what you're going to end up with is you're going to have the oxide, and you're going to have both of your aromatic rings attached like this. And so the last step is just going to be to treat it with H3O plus, but this is going to do 2 steps at once. 2 steps at once, right? It's going to do the protonation to put the proton on here, but it's also going to remove the acetal to restore the ketone. So there you go. So now we've discussed hemiacetals, acetals. We've learned how to make a hemiacetal, how to make an acetal. We talked about a carbonyl being an electrophile. We talked about how an oxonium is a more powerful electrophile. We've talked about the nomenclature of aldehydes and ketones. And we'll call it a day for there. And on Wednesday, what we'll do is we'll get into section 19.6. So let me just show you quickly. We're going to get into section 19.6. So let me find it all the way down here. Yeah, so we're going to get into section 19.6, where we're going to talk about imines, And then once we're done talking about imines, we're going to talk about enamines. Then once enamines are over, we're going to talk about a hydrazine, a hydrazone, and then we'll talk about an oxime and all these different functional groups. And so let's just go down to the end of the slides here and see what we've covered today. So far what we've covered here is we've covered the formation of a hydrate, then we covered the formation of an acetal, then we covered the formation of a cyclic acetal, and I guess that's really it. And so next class, really what we're going to start with is kind of this chemistry in this portion here. We actually talked about this today. We did cover a little bit of Grignard and a little bit of reduction today. But yeah, we're going to get into nitrogen chemistry at the beginning. And then after that, we'll get into the Grignard and into the Baeyer-Villiger reaction.